Hello and welcome Mr. Wiley Teaches Math. Today we're going to be trying to figure out possible equations from graphs. In the last time we were exploring y is equal to mx n plus b, or negative mx n negative b, and seeing how that affected our graph. So from this, we should have found that as the m value increases, like to 2 or 3, that your steepness, the slope of the graph increases. So we should have found that instead of being a nice gentle slope as we get 2 or 3, our graph goes from y is equal to x, which looks like this, to getting steeper and steeper and steeper. For the b, we should have found that that affects where it crosses the x-axis. So where does it intercept the x-axis? So if this was plus b, plus 2, I would be expecting it to cross the x-axis at 2 above the y-axis. I'd be expecting it to cross there. If it was negative 1, I'd be expecting it to cross down here. The n, or the exponent, we should have found changes the shape of the graph. That our graph starts as a straight line, mx plus b, but if we change it to an exponent of 2 or to 3, then the whole shape of the graph is no longer a straight line. Should have also found that a negative m value flips the whole graph around. Instead of going as y to x goes in this direction, we should have found that y is equal to negative x goes in the opposite direction. Should have found for powers of 2 or powers of 3 that the whole graph gets flipped as well. Should have found that negative, as I mentioned before, this is going to affect the x-axis intercept. In this case, it's going to be below the y-axis. So knowing these things, we can try to hypothesize possible equations from graphs. So let's take a look at, I think I have 9 of them here today. So let's look at our line number 1. And let's try to keep those things in mind. Look at the slope, or the m value. It's 1 over and 1 up. So it's just a slope of 1. So I'm not actually going to write that. So y is equal to, there's no m value, so just x. Then I'm going to look at where it crosses the y-axis. And it crosses at positive 1. So y is equal to x plus 1. For my second line, I notice that the slope is over 1 and up 1, 2, 3. So it's a slope of 3, so my m value is 3. It crosses the y-axis at 3, so it's 3x plus 3, and it's a straight line, so there's no exponent. And it's going in this direction, it's in a positive direction, positive relationship. And my third one, I notice that the slope, here's a good spot, is over 1 and up 2. So it's going to be a slope of 2, and it crosses at negative 6. It's a straight line, so there's no exponent. It's still going in this direction, the positive direction, so it's positive 2x subtract 6. Notice that these are going in the opposite direction before, so I'm going to expect negative values on this. They're still straight lines, so I'm not going to be changing the exponent. Just going to be changing the slope and where it crosses the y-axis. So let's take a look at line number 5. I notice that it's got a slope, the negative direction of 1 and 1 up. So it's going to be a negative, but a negative 1, which I don't have to write, so I'm just going to write it as negative x. And where does it cross? It crosses at positive 6. So negative x plus 6. And I just think I did that on the wrong line. Let's just change that to a 5 and that to a 4. And now all is good. All right, number 4. This line here, you notice it crosses through the origin, so it's not going to have any plus or minus on the end. I notice that the slope is -1 and 1, so I'm just going to write that as a negative, because I don't have to write the 1, negative x. As I said, it crosses at 0, so it's plus or minus 0, which I don't write. So this is simply y is equal to negative x. And finally, line 6. So I'm going to find the slope. See, it's a -1 in that direction, going the negative direction, and up 2. So I'm going to write that as -2 x. It's a straight line, so I'm not going to worry about exponents. And I'm going to look at where it crosses. It crosses at -8. So I'm going to write that as subtract 8. So the equation for that line is -2x subtract 8. For these ones, notice that the shape has changed. So I did this as a table of values for number 7. I noticed that 0 and 0 is a pair, 1 and 1 is a pair, -1 and 1 is a pair, 2 and 4 is a pair, but -2 and 4 is also a pair. And if I kept going, I could say that 3 and 9, -3 and 9, that'd be 4 and 16, -4 and 16. And for this, I notice that in each case it's a squared. It's going to be x squared. It's crossing through the origin, so it's +0. And this is actually just the normal slope because we haven't added or multiplied it again at all. So this equation would be x to the power of 2. This one's going to be very similar. It's the flip. It's the downward direction, so I'm going to expect it to be a negative. In this case, it crosses at -3, so it's going to be negative x squared subtract 3. And I can see that follows the same pattern before, that it goes over 1, down 1, 1, 1, 2, and 3, 2 and 3, and so on. So it's still the negative value. And finally, we have this one, which is y is equal to x to the power of 3. Just checking that I actually finished that one off. Yep. Y is equal to x to the power of 3. In this case, the shape changes again. We've got this shape. The negative value is going to do something similar. I'm just going to sketch it out really quick, get some of the key points. The negative is going to go and look like this, a little bit off there. So it's still a flip, it's still a mirror image, but because it crosses the y-axis like that. So thanks for watching. Be sure to check the class website for the assignment, additional examples, and the handouts.